Good day, class. This is Sir Emilio Titare Jr. and welcome to another mathematics class. Today's topic is the fundamental counting principle. Our objectives are the following. Illustrate the three diagrams, define and apply fundamental counting principle, and simplify and perform operations on factorial notations. First, let us define the three diagrams. It is a method that shows all the possible outcomes of an event by using branches. So for example, we have here a coin. So um, ngayon, ililista natin or um, kukunin natin yung number of ways or number of outcomes ng pag-toss ng coin. So sa unang toss natin, there are 50-50% chance na maging head or maging tail or hati sila ng chance. And of course, sa pangalawang toss natin, another half. So for example, kung head yung unang toss natin, then there are another 50% chance na head ulit ating. So, ganun din. Kapag tail naman yung unang toss, may chance na head yung second or tail. So, as you can see, yung kalahating chance na nangalahati pa. And, ito yung mga possible combinations ng outcomes natin or arrangement ng outcomes natin. So, pwedeng head-head sa first and second toss, pwedeng head-tail sa first and second toss, tail-head, and tail-tail. So, as you can see, we have here 4 outcomes. So, kapag bina-branch out natin using three diagrams, mas malinaw at mas nakikita natin kung yung mga possible outcomes. Next natin ay, if you choose one burger, one side serve, and one drink, how many combinations or outcomes are possible? So, sa burger natin, meron tayong tatlong choices which are beef, chicken, and fish. Sa side serves, we have fries and salad. And sa drinks, we have cola and juice. So, ayan, i-branch out natin. Sa burgers, meron tayong tatlong choices. Then, bawat choices natin or bawat burger option natin, pwede natin partneran ng fries or salad. Ayan. And next, i-branch out natin ano ba yung mga available na drinks, cola and juice. So, bawat fries and salad, pwede natin partneran ng cola or juice. Ayan. Okay. So, dito, ilang combination or ilang possible outcomes na yung pwedeng mapili. So, pwedeng burger, fries, cola, burger, fries, juice, burger, salad, beef, salad, cola, beef, salad, juice. Ayan. And all in all, there are 12 possible outcomes. So, sa tree diagram, mas nakikita natin, mas na-visualize natin yung mga possible combination ng outcomes. Next. Listing method. Ang listing method naman is dito natin nililista or we will just write down all the possible outcomes. Katulad nga lang dun sa ating 2 coins or sa pag-toss ng coins ng ating coin twice. So, pwedeng head-head ang first outcome, pwedeng head-tail, pwedeng tail-head, pwedeng tail-tail. Now, let's proceed to the fundamental counting principle. The fundamental counting principle states that if there are p ways to do one thing and q ways to do another thing, then there are p times q ways to do both things. So, itong fundamental counting principle natin is parang sinasabi lang na para malaman natin ang totality ng ways of doing a combination or series of events, i-multiply lang natin yung ating mga possible outcomes per event. So, for example, sa ating pag-toss ng coins, ilan ba yung possible outcomes natin sa first toss? Di ba dalawa? And sa second toss natin, dalawa din. So, all in all, kapag multiply natin using the fundamental counting principle, magiging 4 na yung ating possible outcomes. Gamitan din natin ng fundamental counting principle yung ating burger, side serves, and drinks. So, kung kanina gumamit tayo ng tree diagram, ngayon, gumamit tayo ng fundamental counting principle. So, there are 3 outcomes for the burger, 2 outcomes for the side serves, and 2 for the drinks. So, i-multiply lang natin together, we will get 12. So, there are 12 possible outcomes. So, nakita naman din natin kanina na 12 lang din. Next, using the fundamental counting principle, to make a yogurt parfait, you choose 1 flavor of yogurt, 1 fruit topping, and 1 nut topping. How many parfait choices are there? So, first, dalawa sa ating flavor ng yogurt. Then, sa ating fruit naman ay 1, 2, 3, 4, 5. And sa nuts naman natin, we have 3 choices. So, sa tingin nyo, ilan ang ating possible combination ng ating or possible combination ng ating yogurt parfait? There will be 2 times 5 times 3, which is 30 ways of or 30 parfait choices. Now, a password for a site consists of 4 digits followed by 2 letters. The letter A and Z are not used, and each digit or letter may be used more than once. How many unique passwords are possible? So dito, we have 10 possible numbers which are 0 to 9. Again, kapag digit 0 to 9 lang po ito, so there are 10. And there are 26 possible letters in our English alphabet from A to Z. So again, there are 1, 2, 3, 4 digits and followed by 2 letters. So for the first place, we have 10 options for the digit. Per place or per digit, we have 10 options. Kaya naman 10 ang multiplier natin dito. And sa letters naman is 24. Why? Kasi nga, A and Z are not used. So, B to Y lang ang pagpipilian natin. So, kapag kinuha natin yung product, there will be 5,760 ways or 5,760,000 possible passwords. Now, paano naman if a password for a site consists of 3 digits followed by 2 letters? Each digit or letter may not be used more than once. How many unique passwords are possible? So again, 10 possible digits and 26 possible letters. Pero ang restriction dito, bawal umulit ng digit or letter. So again, meron tayong 3 digit at followed by 2 letters. So ang unang ilalagay natin dito is 10 because we have 10 digits. Then, multiplied by, next natin is 9. Bakit po 9 na lang? Kasi, nagamit mo na yung isa eh. From 10, siyam na lang yung choices mo dito. Kasi nga, bawal umulit. So, kung 9 na dito, sa pangatlong spot natin is 8 na lang po. Kasi po, yung dalawa is nandito na at bawal silang umulit. And pagdating naman sa letter, 26 meron tayo. Then, sa tingin nyo, sa last spot, we will have 25 na lang. Bakit po? Kasi po, bawal nga umulit. So, yung isa, taken na. So, 25 na lang yung choices mo dito. And kapag kinuha natin yung product, we will get 468,000 possible passwords. Okay, next. Let's go to the factorial notation. N factorial is denoted by n exclamation point. Again, ang basa po natin dito is n factorial. Ito lang yung symbol niya with n and exclamation point. It is the product of all positive integers less than or equal to n. So, kung meron tayong n, i-multiply mo siya sa sarili niya times the number lower than it by 1, then mas mababa ng 2, mas mababa ng 3, hanggang mauwi na lang tayo sa 1. So, for example, we have 4 factorial is equal to 4 factorial, tapos multiply siya sa, or 4 times 3 factorial. Ano bang ibig sabihin ng 3 factorial? So, magiging ganito po ang itsura niyan. 4 times 3 times 2 times 1. Again, ang 4 factorial, multiply mo siya sa number itself and sa mga number na mas mababa sa kanya ng paisa-isa. Whole number na mas mababa sa kanya hanggang sa 1. So, 4, 3, 2, 1. Or times 4, 4 times 3 times 2 times 1, which is equal to 24. So, ito po ang ating factorial notation. So, kapag 0 factorial equal to 1, ang expanded form is 1 lang din at same lang sila ng 1 factorial. Pagdating po sa 2 factorial, 2 times 1, which is equal to 2 times 1 factorial, or 2. Then 3 factorial is 3 times 2 times 1. 4 factorial, which will be equal to 24. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or simply 9 times 8 factorial, or 362,880. Ngayon, let's operate some factorial. So, dito, ang una natin gagawin, lagi natin i-evaluate muna. Ano bang ibig sabihin ng 4 factorial? Eh, di 4 times 3 times 2 times 1. Ang 2 factorial naman is 2 times 1. So, kunin muna natin yung, evaluate muna natin sila individually, tsaka natin sila i-operate. So, 4 factorial is 24 and 2 factorial is 2. Kaya naman, 4 factorial plus 2 factorial is 26. Next. So, that's how we add. Ngayon naman, we have same 3 factorial. So, 3 factorial is 3 times 2 times 1. Kaya, ayan po ang nakasulat dito. And same. So, that would be 6 plus 6, which is equal to 12. Again, 3 factorial plus 3 factorial is 12. Next is 6 factorial minus 3 factorial. So, again, expand lang muna natin and evaluate natin sila individually. Tsaka natin makuha ang 720 minus 6, which will be equal to 714. Now, multiplication natin po tayo, tapos na tayo sa addition and subtraction, multiplication po. So, same lang din, evaluate natin sila individually. 5 factorial is 5 times 4 times 3 times 2 times 1 times 2 factorial, which is 2 times 1. So, that would be 120 ang product netong ating unang set. And ito naman ay 2. So, kaya naging 120 times 2, which will be equal to 240. Again, 5 factorial times 2 factorial is 240. Next example, 7 factorial divided by 4 factorial. So, dito, pwede natin siyang i-expand at mag-stop na lang sa 4 factorial. Ano bang ibig sabihin ng 4 factorial? Di ba ang 4 factorial is 4 times 3 times 2 times 1? Eh, same lang dito yon. So, since same lang naman sila, at may kamukha na siya dito, may common factor na po. So, pwede tayo mag-stop at hindi na i-list times 3 times 2 times 1. So, just simply 4 factorial. At pwede natin silang i-cancel out or i-reduce into 1. So, matitira na lang is 7 times 6 times 5. And ito po yung expanded form niya, di ba? So, kung mapapansin natin dito, pinahaba natin and expand talaga natin. And, oops, ayan, same lang naman ng mga ma-reduce into 1 or maka-cross out. So, tanggal na yung 4, 3, 2, 1. Or just simply 4 factorial. Hanggang ang technique natin, kung ano yung divisor natin, i-expand natin to at pag may nakita na tayong kamukha sa divisor, mag-i-stop tayo. So, lilista natin 7 times 6 times 5 times 4. Eh, may kamukha ng 4. So, stop tayo sa 4 para pwede na natin silang i-divide. So, matitira is 7 times 6 times 5, which is equal to 210. Next is 5 factorial over 3 factorial times 2 factorial. So, again, dito, ililista lang natin yung, ayan, 5 times 4 times 3 factorial na lang. Hanggang 3 factorial lang tayo kasi may kamukha na siyang 3 factorial sa baba. So, anong matitira? Eh, di 5 times 4 over 2 factorial. Eh, ano ba ang 2 factorial? Ang 2 factorial is 2, diba? So, kaya naging 2 na lang. Then, 5 times 4 is 20, kaya 20 over 2. Then 20 over 2 is 10. So 5 factorial over 3 factorial times 2 factorial is equal to 10. Next, how about this one? K factorial over quantity k minus 1 factorial. So kapag in-expand natin yung k factorial, that would be, di ba magma-minus tayo na magma-minus sa value ng k ng isa? Eh biglang, or sorry, eh may kamukha na siya dito agad. So kahit k minus 1 pa lang, hindi na tayo pumunta sa k minus 2, k minus 3, may kamukha na siya dito. So pwede natin tong i-cross out. Then it will be equal to k na lang matitira. So the answer is k. Good day, class. This is Sir Emilio Titare Jr. and welcome to another mathematics class. Today's topic is permutation. Our objectives are recall factorial notation, find the number of permutation on n objects taken r at a time, and solve problems involving permutations. So, given 3 letters A, B, and C, take 2 letters at a time. So, ang gagawin lang natin is ilista natin. Meron tayong tatlong letters which are A, B, and C. Then, ang gagawin natin, gagawa tayo ng arrangements using 2 letters at a time. So, ano-ano yon? A, B, A, C, B, A, B, C, and so on. So, ito po. We have here, yan. We have here 6 arrangements na nagawa. So, ayan. As we can see, using the listing method, 6 arrangements yung nagawa natin. Pero, we have a formula. So, ang basa natin dito is permutation of 3 objects taken 2 at a time, which is equal to 3 factorial over quantity 3 minus 2 factorial. And this one will be just 1 factorial, which is equal to 1. Kaya 3 factorial na lang matitira sa taas, which is equal to 3 times 2 times 1, which is 6. So, nag-match po, di ba? To understand it fully, let's have this one. Permutation is an arrangement of objects in which order is important. So, we have two formula. This one and this one. So, basically, ang pinagkaiba neto, sa Formula 1, gagamitin natin siya kapag hindi equal ang R at ang N natin. Ano ba ang N natin? Ito yung N, ito yung total number ng ating elements or ng ating i-arrange. Samantalang ang ating R naman is kung ilan lang yung kailangang i-arrange. So, for example, kanina, 3 yung ating letters, so 3 ang N, then 2 lang yung kailangang kunin or 2 letters at a time lang. Ngayon, kapag ang R naman is equal to N or kung ano yung kailangan natin or kung ilan yung elements din natin, kukunin natin lahat or i-arrange natin lahat. Ang formula natin is P is equal to N factorial or permutation of objects is equal to N factorial. So to better understand it, let's have this one. So using the formula 1, let's solve this. Permutation of 7 objects taken 2 at a time. Again, ang basa po natin dito is permutation of 7 objects taken 2 at a time is equal to, ayan, palitan natin yung N ng 7 and yung R naman is 2. So, ano pong magiging tsura next natin? Ang ating denominator is 7 factorial while our numerator is 7 factorial and the denominator will be 5 factorial. So, evaluate natin yan. Magiging 7 times 6 times 5 factorial. So, cancel na yung 5 factorial kasi may 5 factorial din dito. So, ang matitira na lang po is 7 times 6. And 7 times 6 is 42. So, the permutation of 7 objects taken 2 at a time is 42. Next, using the formula 1 as well. So, again, ang basa natin dito is permutation of 6 objects taken 4 at a time is equal to, palitan yung N ng 6 and yung R naman ng 4. So, ano na lang magiging denominator natin? 6 minus 4 is 2. Kaya 2 na lang po ang natira dito. So, kapag in-expand natin to 6 times 5 times 4 times 3. times 2 factorial. 2 factorial, pwede natin i-cross out dahil common factor. So, matitira na lang is 6 times 5 times 4 times 3. And the product of those numbers is 360. So, again, the permutation of 6 objects taken 4 at a time is 360. Next, formula 2. Using the formula 2, we have permutation of and permutation is equal to n objects. So, ang permutation natin will be 5 over 5 over ito, isa-solve lang natin siya ng using the first formula. Pero, kung papansin natin, same lang ang magiging sagot dyan. So, 5 minus 5 is 0 factorial, di ba? Ayan, 0 factorial. And we know that 0 factorial is 1. So, basically, magiging 1 na lang to. So, magiging n factorial over 1. Kaya, pinakita po natin dito na magiging 0 lang lagi ito kasi nga equal lang n tsaka yung r. And 0 factorial is 1. So, since 1 na lang ang denominator, yung numerator na lang matitira. Kaya ano bang numerator? N factorial or 5 factorial. Kaya naman, dito, the answer will be simply 5 factorial, which is 120. Again, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So, the permutation of 5 objects taken 5 at a time or taken all is 120. Again, ito po yung formula na gagamitin natin, ha? So, kung anong value ng n, if factorial lang, kunin lang natin yung factorial value niya. So, next. How many permutations are there in the word hope if the letters are taken 2 at a time? So, ilan ba ang letters meron ng hope natin? 1, 2, 3, 4. So, taken 2 at a time. So, ang R natin is 2 at ang ating N is 4. So, magiging permutation of 4 objects taken 2 at a time will be equal to, palitan yung N ng 4 and minus yung R naman ng 2. So, anong mangyayari sa denominator? Magiging 2 na lang po. So, 4 times 3 times 2 factorial ito. Cross out yung 2 factorial, magiging 4 times 3 na lang, which is equal to 12. So, again, the permutation of 4 objects taken 2 at a time is 12. Or, permutation ng word na hope if the letters are taken 2 at a time. So, 12 po ang sagot natin dyan. Next, determine the number of ways can 4 boys and 4 girls be seated in a row of 8 seats given the following conditions if they may sit anywhere. So, dito meron tayong 4 boys and 4 girls. So, since lahat naman dito ay pwedeng umupo kahit saan. So, this will be just, and ang n natin dito is 8, ang r natin dito is 8. So, 8 factorial lang ang sagot, which is equal to 40,320 ways. Next. Same problem or same scenario, and the problem is the girls are to be seated together. So, yung girls, gusto nila magkakatabi sila. So, ang mangyayari sa kanila, counted sila as 1. Counted as 1. So, meron tayong 1, 2, 3, 4, 5. Kaso lang, itong mga babaeng to, pwede din po silang i-arrange. So, anong mangyayari sa ating formula? Dito po ipasok yung fundamental counting principle. I-multiply natin yung number of ways na pwede nating i-arrange yung mga babae at yung number of ways na pwede silang i-arrange yung mga babae with the boys. So, saan po iyon? Ito po, 5 factorial times 4 factorial. Saan galing yung 5 factorial? Again, counted as 1 itong mga babae. So, 1, 2, 3, 4, 5. And saan naman galing itong 4 factorial? Kahit counted as 1 sila, pwede silang i-arrange into different ways. Kaya meron tayong 4 factorial. So, 5 factorial times 4 factorial will be 2,880 ways. Next, same problem or same scenario. The problem is they are to be seated alternately by gender. So, dito, meron tayong dalawang case. Pwede mauna ang boy, pwede ding mauna ang girl. So, kapag taken ni Jeff yung unang upuan, syempre, 3 na lang yung pwede nating pagpilian sa pangalawang seat for the boys. Kung taken na ni Kat yung unang upuan, Para sa babae, yung next seat is tatlo na lang yung pwedeng pagpilian. And dito, dalawa na lang kasi nakaupo na yung dalawang boy. Same as here. Then dito, last na lang. Sa last natin is 1. So kung mapapansin natin, same scenario lang din po. So dito, ang magiging itsura ng sa case 1 natin is 4 factorial times 4 factorial, which is 576 ways. Next is, yung case 2 natin, same lang din. Nauna nga lang yung girls. So, ang gagawin natin, i-multiply lang natin sa 2 yung 4 factorial times 4 factorial, which is 1,152 ways. Now, Jeff and Kat must insist on sitting next to each other. So, gusto ni Jeff and Kat magkatabi sila. So, counted as 1 sila. So, kung meron tayo 8, ang originally 8 seats meron tayo, magiging 7 na lang kasi counted as 1 si Jeff and Kat. Pero si Jeff and Kat, pwede silang i-arrange in different ways. So, ang kanilang ganito maging itsura ng ating permutation. 7 factorial kasi si Jeff from 8 naging 7 na lang dahil nga si Jeff and Kat counted as 1. Then, times 2 factorial. Kasi nga po, pwede nating i-arrange in different ways si Jeff and Kat. So, 7 factorial times 2 factorial will be equal to 10,080 ways. Ngayon naman po, paano kapag 4 pairs must be seated next to each other? So, magiging 4 na pares. Dahil 4 na pares na, 4 na grupo yon. So, bawat pares is counted as 1. So, 4 factorial po. Saan naman po galing itong 4 na 2 factorial? Siyempre po, bawat pares na yun, dahil 4 na pares yun, 4 na 2 factorial. At bakit 2 factorial? Kasi nga po pares. So, bawat pares may dalawang or may 2 factorial ways to arrange it. And kapag kinuha natin yung product din na to, it will be 384 ways. Next, punta tayo sa circular permutation. It is the arrangement of things in a circular pattern. So, meron tayong dalawang formula. Itong P is equal to quantity n minus 1 factorial and the keyring, which is P is equal to quantity n minus 1 factorial all over 2. So, ano ba yung keyring? Pag sinabi natin keyring, ito yung kung may keychain tayo, diba may bilog na nag-hold sa keyring at sa keychain. So, yung bilog po yun yung keyring. At yung keyring, pwede natin siyang tignan. Itong pangalawang formula natin, ginagamit natin siya kapag pwede nating pagbaliktaran or pwede nating makita sa dalawang side yung circle. So, siyempre, circular permutation, i-arrange mo to ng pa-circle. Yung kanina, ina-arrange ng palinear. Palinya, papila. Ngayon, ito naman po ay pabilog. So, may dalawa tayong formula. Again, ginagamit natin to kapag dalawang side yung pwede natin makita. Ito naman po kapag isang side lang. So, for example, ang ating merry-go-round. How many ways can 5 different colored toys horses be arranged in a merry-go-round? So, itong merry-go-round, pabilog siya. And kapag ginawa mo siyang 2-dimensional, naka-flat siya sa surface. So, makikita mo lang siya from top view. Siyempre, hindi ka pwedeng pumunta sa ilalim ng lupa at tignan from the bottom view, di ba? So, ang ating formula gagamitin is the first one. So, ang n natin is 5 minus 1 or quantity 5 minus 1 factorial. So, magiging 4 factorial and 4 factorial is 24. Now, eto, a keyring has 4 keys. Again, ang keyring pwedeng pagbaliktarin to. May dalawang side. So, how many ways can they be arranged? Magiging quantity 4 minus 1 factorial over 2, which is 3 factorial over 2, and that is 6 over 2. Again, ang 3 factorial is equal to 6 over 2, which is equal to 3. Now, ang bracelet, pwede ba natin pagbaliktarin to? Dalawang side ba ang bracelet? Yes, dalawang side. Kaya yung second formula yung gagamitin natin. So, how many ways can 5 different colored beads be arranged on a bracelet? So, magiging quantity 5 minus 1 factorial over 2. And 4 factorial ang magiging sagot sa 5 minus 1. So, and what is 4 factorial? 4 factorial is 24 over 2. And 24 over 2 is equal to 12. Now, let's proceed to the distinguishable permutation. Ano kung distinguishable permutation na to? That is a permutation with identical elements. So, may mga nauulit, may mga magkakamukha. So, ito yung formula natin. N factorial is equal over, P is equal to N factorial over P factorial times Q factorial times R factorial and so on. Kaya and so on to, ibig sabihin tuloy-tuloy lang, depende po kung ilan yung umuulit na element. So ngayon, find the number of distinguishable permutation of given letters. Leave the answer in factorial notation. So dito meron tayo tatlong A, isang B, isang C. At ilang elements lahat? 5 po. Kaya ang magiging itsura ng numerator is 5 factorial kasi 5 po ito. At saan galing tong 3 factorial? Dito po yun sa tatlong A. Ang 1 factorial galing sa B at ang 1 factorial ay galing sa C. So basically ito, ano bang ang 1 factorial is equal to 1, 'di ba? So kahit hindi na natin sila isama sa mga susunod na slide natin. Ito, number 2, 143, 143, 143. So meron tayong tatlong 1, tatlong 4, tatlong 3. At ilan lahat 'yon? 1 2 3 4 5 6 7 8 9. So 9 elements or 9 numbers. Pero bawat see? Okay. So, umulit pala ang 4. So, 1, 4, 3, 1, 4, 1, 4, 3, 4. Hindi pala 1, 4, 3, 1, 4, 3, 1, 4, 3. So, pero 9 factorial pa din. So, tatlo yung 1 natin, kaya 3 factorial. Then, ang ating 4 is 1, 2, 3, 4, 4 din. So, 4 factorial. At ang ating 3 naman ay dalawa. So, 3 factorial. Dito lahat umuulit. And sa word na Philippines, ilan bang letter to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 ang numerator. Ilan ang P? 1, 2, 3. Or sorry, 12 pala. Then, ilang H? Isa lang. Tatlong I. Isang L. Then, given na yung I, given na yung P, given na yung I ulit. N, isa lang din, E isa lang din, at ang ating S ay isa lang din. Kaya naman ganito ang itsura ng ating factorial. So, punta tayo sa next slide. Hindi pa natin na-evaluate, nilista pa lang natin. Ngayon, sa word na quarantine, ilang letters lahat yan? 10. Ngayon, ang gagawin natin, didedmahin natin lahat ng single letters or yung mga elements or mga letters na hindi umuulit. Katulad ng Q, ng U, R, P, at I, E. Ano lang umuulit? Edi letter A at letter N. Kaya, dalawang A, dalawang N. So, 10 factorial, 10 letters lahat, over 2 factorial times 2 factorial. Pwede natin isulat yung 1 factorial, yung 6 na 1 factorial. Pero, equal lang naman yun sa 1 kapag multiply mo. So, ang importante lang yung mga umuulit na letter. So, makukuha natin sagot dyan is 10 factorial over 2 factorial times 2 factorial is 7,200. Next dito, the word struggle. Ano ang mga letter na umuulit? Letter G lang po. So, ilang letter G? Dalawa. Then, ilang letter lahat? 1, 2, 3, 4, 5, 6, 7, 8. So, 8 letters. So, 8 factorial over 2 factorial, which is equal to 8 times 7 times 6 times 5 times 4 times 3 na lang kasi cancel lang yung 2 factorial. And that is 20,160. Next, vaccine. Ano mga letter na umulit? C lang din po. So, ilang C? Dalawa. So, ang numerator is 2 factorial. How about denominator is 2 factorial. And the numerator will be 1, 2, 3, 4, 5, 6, 7. And that is 7 factorial over 2 factorial, which is equal to 2,520. Next, Mr. 1 is a doctor who has 5 Sinovac vaccine, 4 AstraZeneca, and 4 Pfizer. And how many ways can he arrange this vaccine in a shelf? So, again, ito po yung mga meron si Mr. 1 or si Dr. 1. And ilang lahat yan? 5 plus 4 plus 4 is equal to 13. So, 13 ang numerator, samantalang ang denominator is 5 factorial times 4 factorial times 4 factorial, which is equal to, evaluate nyo muna to, then evaluate nyo din tong denominator, tsaka nyo i-divide, makuha is 90,090. So, that would be all for today. Stay home, stay safe, and save lives. This is Sir Emilio Titaro Jr. Goodbye, class!